Okay, so now we're doing exercise 12.7, where we have this graph right here. The first thing we're asked to find is the notation angle theta. Oh, actually, let me write down the first things. We have I1 is equals to I2, which is equals to 150, and I3 is equals to 30. And meanwhile, it's a prolate because I3 is less than the rest. It's a prolate body. And we know that omega 3 is a constant and it is 0.6 radians per second. Alright, so we have okay. Now we want to find the nutation angle, which is theta, which is equal to tangent to the power of -1 of h12 divided by h3, where h12 is equals to the square root of h1 plus square root of h2 squared. Okay, so let's start finding h1 and h2. h1 is equals to I1 times omega 1, and then h2 is going to be equals to I2 omega 2. So in order to get those, we have to look at our velocities here. What I want to do is, instead of taking the initial values right here, I'm going to take the maximum here, and it's going to be a 0 here, because our omega 1 squared plus omega 2 squared have to be equal to a constant, which in this case is equals to 0.1. Okay. And of course, this conservation momentum, so we have all the entire time. So let's get rid of one of these information and just look at, for example, omega 1. Then we're going to have 150 times 0.1, which is simply equals to 15. Okay, so now tangent to the power of -1. Oh, actually, we have to find h3. h3 then is equals to 30 times 0.6, which is then 18, I want to say. Let me just check. 30 times 0.6. Yes, it's 18. Okay, then we have tangent power of -1 of 15 over 18. 15 over 18 is equals to 0.6947 radians, of course. And we can convert this to degrees, and it's going to be equals to 39.81 degrees. Now for part B, we have to find gamma. The angle gamma then is instead tangent power of -1 of omega 1, 2 divided by omega 3, where omega 1, 2 is equals to, similar to our h before, h1, 2, omega 1 squared plus omega 2 squared, square root. However, this means it's just going to be the 0.1, and therefore our tangent power -1 of 0.1 divided by 0.6, or 1 over 6 really, is equals to 0.165 radians per second. Oh, radians, sorry, that's just an angle. And then to convert it to degrees, we get 9.46 degrees. There you go. Make sure these are all right and well. Yes, okay. Then for, well, taking this up part B and all that, but I'm just writing like this is 12.9, I guess. Determining the precession rate of phi dot, which is then equals to I3 phi dot, sorry, this is psi dot, divided by omega I3 minus I1 times cosine of theta. So in order to find phi dot, which is equals to negative lambda, we need to use our formula that is equals to I3 minus, minus I3 minus I2 divided by I1 times omega 3. And that is 120 divided by 150 times 0.6. So here we have a 2.4 divided by 5. So about 0.5 or 0.48, but we had a negative in front, so it's going to be a negative 0.48. sorry, no, this was a negative 120. So this actually ends up being a positive for the phi dot. So this is equals to our phi dot. Okay, now we can plug it in here. So we have 30 times 0.48 divided by 120, negative 120, I guess. No, positive 120 times cosine of, oops, this is supposed to be 1, 3, or 2. It looked like a 3 to me. Cosine of the angle that we found earlier. So it was it was 39.81 degrees. So let's change that into degrees. We have 30 times 0.48 divided by 120 times cosine of 39.81, which is equals to 0.156. Then we can convert it to radians. So we convert it to degrees, and then it equals to 8.95 degrees. Now, interestingly, even though I plugged in degrees in here, the cosine of a certain degree returns a variable-less value. Therefore, this was going to be variable or unitless. So we plug in radians because radians is not technically a unit of measurement or a unit. So we can plug in whatever we want pretty much, and therefore we say the radians and then 8.95 degrees after. Okay, well, we just solved D already by doing this. Let's convert it to degrees. So we have, of course, see here as well, we have no units, so we just plug in a radians. So we say 0.48 times 180 divided by 5, divided by E, my calculator, is equals to, 27.50. Okay, now the next step is E. Determine the Euler angle phi at time 0. So for this, we can use our equation that says that phi is equals to pi over 2 minus lambda t minus beta. Now, we don't really care about lambda in this case because it is going to be 0, t is equals to 0. However, beta we need to find. How do we find beta? Well, beta will come from our equation for omega 1 is equals to omega 1 2 cosine of omega t plus b. Right. So at time, so omega 1 2 is something we calculated earlier. Let's see where it was. I can't find it anymore, but I'll just calculate it again. So let's take omega 1 2 to, what we said was equals to 0.1 because we set it all the way up here. Okay, and then we say at time 0, so this one has to go to 0. And what is the value of omega 1 at time 0? Well, it's equals to 0.9. So omega 1 is equals to 0.9, which is equals to 0.1 times cosine of beta. So here we get 9. No. Yeah, hold on. I'm doing something incorrectly. We obtain our beta. There should be 0.5 in here. Let me do it with omega 2. Let's do omega 2 right now. Just oh no, this is just 1 because yeah. There we go. Is it no? No, it should be 0.1. Let's do it with the omega 2. Just you can see, it's gonna be the same. So omega 1 2 is equal times cosine of beta. Now omega 1 2. Oh yeah, omega 1 2 is 1. Then never mind. And then here we have to have 0. 0.05. I feel like there's omega 1, 2 should be 0.1. I'm gonna keep omega 1, 2 here. Anyhow, in the meanwhile, it should be 0.05, but it ends up being then 0.5. Yeah, omega 1, 2 is 0.1. Because if I plug in 0.05 on the left side and 0.0 and 0.1 over here, and cosine of beta, because lambda t equals to 0, because it's a times 0, then I get 0.5 is equals to cosine of, sine of beta, because it's omega 2. Sine of beta. Therefore, beta is equal to sine to the power of negative 1 of 0.5, which then equals to 30 degrees. Then I go back, or was it pi over 6? Yes. Then I go back here, I have pi over 2 minus pi over 6. So then I get 2 or 1, just pi over 3, which is then equal to 60 degrees. Yeah. Oh, I see what I did wrong over here. So let me just go back to clear out doubts. It's 0.09, the actual value that I had over here. So I ended up getting with the 0.9 on the left side times cosine of beta by plugging in 0.1 for omega 1, 2. Therefore, beta would be equals to cosine of the power of negative 1 of 0.9, which is still going to be pi over 6. I can plug in just to make sure. 0.9 is equals to 25. Yeah, 25 degrees. 25 degrees I can convert it to radians, so divided by 180 times pi is equals to 0.45. Yes, because 1 over 6 is, yeah. Okay. And that's the end of this problem.